Bismillahirrahmanirrahim. Good afternoon, students. Today we will discuss Snape and Ladder problem. The problem says that Professor Snape has lots of potions. Bottles containing all types of potions are stacked on shelves, which cover the entire wall from floor to ceiling. Professor Snape has broken his bones several times while climbing the top shelf for retrieving potion. He decided to get a ladder for him, but he has no time to visit diagonally. So he instructed Ron Rewelsi to make a ladder for him. Professor Snape specifically wants a stepped ladder that looks like an inverted V from side view. So Professor Snape has a lot of shelves that full of bottles, and each time, sometimes he broken his bones while he tried to catch or to pick some of these bottles. So Professor Snape عنده مجموعة من الزجاجات زجاجات الأدوية مرتبة على الأرفف، والأرفف ارتفاعها تقريبا من الأرض إلى السطح إلى سقف الغرفة، فكان أحيانا ممكن يكسر جزء من الأرمز أو رجله أو إيده while he trying to pick some of them عندما كان يحاول إنه يلتقط بعض من هاي الباتلز. So he asked his friend to buy or to design a ladder for him. سلم. فالسلم when we look at the ladder from the side، لما نطلع عليه من جهة مقطع جانبي لللادر أو للسلم، يبدو بشكل triangle as we see here in this image. So the ladder looks like a triangle, or we can imagine it as a triangle. Now the ladder is not fixed in this way. We can move the sides, the right side, the left side, and the base here represents the distance between the left and the right side, or the base of the triangle. So this kind of ladder, as Professor Snape asks Ron to design, could be moved or changed in two ways. So we have to find, the problem asks us to find the length of the right side. Now we don't have actually one value for the right side. Instead we have two values for this side, and these two values depends on the shape of the triangle that will be result while we moving the angle of the triangle, or when we change the shape of the ladder. Let's continue reading the task. The task says also Professor just mentioned two things before vanishing. B represent the the separation or the distance between the left side and the right side, and LS represent the length of the left side. What should be the length of the right side? This is the question. At one extreme, this is a very important note, at one extreme left side can be vertical, and at other right side can be vertical. So these two cases could help us to understand the situation or the shape of the ladder. So we have two values now of right side length. The first one here, the right side in his maximum value, or the maximum value of right side will be represented if we have a right angle triangle as we see here, and we can find the right side in this type of triangle using the Pythagorean theorem, the theory ضرية Pythagoras. So the right side equals square root of left side square plus the base square. The other case for this ladder to be when we can move it, and the right side in this case will be in its minimum value. So the minimum value of right side will be as follows. If we use the Pythagorean theory again, the left side square equals b square plus rs square. So rs square will be equals left side square minus b square. Now the right side, the minimum value of the right side based on this theory will be square root of left side square minus b square. This expression is a mathematical expression, and we can convert it to be a C++ expression. So how we can convert the square root? We will use the square root function instead of it, and we may use here the power function POW of LS times 2, which means LS times LS, or we can use simply LS times LS minus B times B, and the priority for production here, or for the multiplication over the subtraction. So he will calculate first the left side times left side, B times B, then we will now subtract B from the left side and find the square root, and this is the value finally of the right side, the minimum value of the right side of this triangle or of this ladder. The constraints for this question is as follow. The base must be less than the left side and both of them must be greater than or equal 1, and this than or equal 1000, and the user must input 2 integer b and left side. So if the user enter 4 and 5, for the base of the triangle will be 4 and the left side will be 5. In this case we have to find the minimum value of r as based on this formula, and then we will see out the maximum side, the maximum value of right side based on this formula. So in this case the problem or the solution is very easy. Simply we can say that we have two values for b and left side. We let the user enter these two values, then we will find the square root of left side times left side minus b times b, and space, then the maximum value of the right side, square root of left side times left side plus b times b, and that's it. Thank you for watching.